Welcome back, viewers. The second part, we are going to look at some of the inheritance that's deviated, that goes against Mendelian's principles. Those three principles we earlier discussed: the principle of segregation, the principle of independent assortment, and the principle of dominance. This inheritance, I'm going to list them as the disobey or deviated from Mendelian's principle. Okay, I will just write inheritance that deviates from Mendelian's principle. Okay, one is incomplete dominance. Incomplete dominance. Okay, we're also going to look at codominance. Codominance and the multiple alleles. We also look at sex linkage. Sex linkage or sex-linked traits. And we'll look at linkage. We look at sex determination, and then finally mutation. 7 of it. Inheritance that deviates from Mendelian's principle. Okay, I'll start with incomplete dominance. The inheritance of incomplete dominance quite deviates from law of dominance. Law of dominance. Remember the three principles. One of the principles is law of dominance. The example of incomplete dominance, Mendel described incomplete dominance using this plant, snapdragon, where he studied two varieties, the red variety, the pure breeding, or the red varieties, red or pure breeding versus whites. Also pure breeding. Okay, the genotype for red is given as this. The one may think that is dominant, and then one may also think is neither is dominant or recessive. The law of segregation, which says that these pairs of genes we separate, like it look like monohybrids, single factor inheritance. But in the cross, this gives this genotype. The second outcome is this genotype. Third outcome is this genotype. Fourth outcome is this genotype. To what surprises Mendel, all these offspring, this outcome here appear to be all pink. Okay, you are crossing a red variety and a white variety, and now you have to see the offspring all pink. In the law of dominance, if red is dominant, all offspring here will appear to be red. If white is dominant, all offspring here will appear to be white. So in the outcome of the F1, neither red nor white appear. So in the case where these both parents were not able to express in the first filial generation, Mendel concluded that the gene controlling these two varieties are neither dominant. There is no clear case of dominant or recessive. So if there is no clear case of dominant or recessive, that means these characters are incomplete since they did not appear in the first filial generation. But out of curiosity, Mendel tried to selfing pink variety, that is selfing pink variety of F1. He will obtain an F2. Okay, selfing this. So if you look at the parental phenotype, he will try to sell by crossing pink variety versus pink variety, and then the parental genotype was the pink had this genotype and then this genotype. So we're going to use P0 square to represent our outcome. P0 square, so this goes here, going to go here and here. So we have this and this and this. So this pair will give you, the first box is red, second box is pink, third box is pink, fourth box is white. So here genotypical ratio, that's our outcome in terms of genotype, is 1 red is to 2 pink is to 2 pink is to 1 white. And then it appears that the phenotypical ratio also appeared to be the same. 1 red is to 2 pink is to 1 white. So in this crossing, the red did not appear in the first filial generation. The white did not also appear. So neither red nor white is dominant, or neither white nor red is recessive, since the outcome only shows pink. So there is no clear case of dominance. That is why this. So example is snapdragon or even 4-o'clock plant. Try to show this. Or 4-o'clock plants show this inheritance fashion. And again, since that is the case, the law of dominance is not obeyed, and also the law of monohybrid inheritance is not also obeyed, because in the F2 generation here, this ought to give us phenotypical ratio of 3 dominant species is to 1. We did not obtain this 3:1 monohybrid ratio, but we obtain ratio of 1 red is to 2 pink is to 1 red. That means the pink that we are not involved in the parental cross had appeared in more ratio than those that we first appeared in the cross. So this is the first inheritance that's deviated, go against the principle of dominance. And then the second inheritance fashion that deviates from Mendelian's principle was the codominant.